we were able to figure out how to get that working for our Logic Apps. Over here. Turns out that our Logic Apps designer was not liking at all. He wasn't liking at all the SQL connector. I'm not sure why, but that's what we ended up figuring out. Try doing this. So we're gonna go to our Logic Apps Designer in order to have the Logic App execute that SQL Server store procedure that we have. That way we can expose our logic via an API. So I got my trigger here, my HTTP trigger here. I'm going to do a new step, and I'm going to tell it that I want to execute a SQL store procedure. I'm going to take a little while, SQL Server, and execute store procedure. The name on the SQL Server, an array. Let me recreate this connection. I ended up having to connect using my AD account, my own AD account. Not sure why the Logic Apps AD account didn't work. But you can start with your AD account as a starting place, and then later on you can adjust the connection so that it connects using probably like a client credentials type of flow. We're gonna use Azure AD integrated. I'm gonna sign in. So here I'm just creating the connection. I'm gonna sign in with my Azure AD user, not my personal email. And the server name, I believe this dropdown still doesn't work. So in here, we're gonna have to use a specific name. So we're gonna go to our server, SQL Server right here. And I'm gonna copy here our server name. Paste that here. And then notice that the database here auto-populates because it was able to connect to the server with this user, and then it was able to figure out that that database was there. So the procedure name, we're gonna look our procedure name should show up here if our database is not sleeping. Yeah. So this will happen because the database is not on yet. Remember that we had our database as a serverless database. So it's probably still waking up. Yep, it says status pause. Go to there. And let's check here. I'm gonna connect using the query editor. So what happened here was that the database is probably still not running. So I'm gonna try again. And this time it's on. So let me try here the Logic Apps again. And please tell me. Let me try enter custom value. I'm gonna refresh this. Do my database, the master procedure. There you go, SP enroll student. So notice it knows the parameters of the store procedure because our store procedure is pretty much structured. in such a way that it's taking two parameters, first name and last name. So I'm gonna take that, first name and last name. And then we're gonna use the last name from the parameters from our trigger. Remember that back on the previous video, we defined our parameters for our logic app. Our parameters were designed using a JSON schema, and the JSON schema was generated from an example. So that's how our logic app knows that it has to take two parameters. Okay, the first name and last name, and then we're gonna return the result of this back to the caller. And to do that, we just try to do, I think it's called response. Let's try built-in. Request, respond, there you go. Okay, so we're gonna respond. So the status code represents the HTTP status code. There are different status codes. 200 means okay, 404 means not found, 500 means an internal error. So you wanna, when doing your APIs, you wanna have a standard where you wanna try to use the semantic status codes from the HTTP standard as much as possible. So for now, we're gonna assume everything went well, and I'm gonna set that 200, but then I'm gonna send as a response back, I'm gonna send the result set. And I believe all we have to do here is, let me go back to the start procedure. The start procedure, what it does is that we just return message status and last name and role. So we want to send that back. So let me do this here. Before putting the body here, I'm gonna compose a JSON. So I'm gonna say compose. That way we compose the JSON before sending it back. So a JSON, again, is a little bit of curly braces. It's a structure with curly braces, like an object with curly braces. Where you have the properties here. So I'm going to name this here, last name role. And then I'm going to give it the last name role from the result sets. Now, notice what it's going to do. It's going to, because with a start procedure, it's going to assume that it's a collection of rows that's been returned. So it's going to try to do a loop. So let's see what it does. So it's doing a for each and a compose. So just to make it clear here, this for each is for each row from SP, from the start procedure. So it automatically did that, and it's looping through those result sets. So I'm gonna cheat a little bit here. I'm just gonna try to add the response here immediately. That way, on the first row, we just return that response back. And I'm gonna tell it that I want to return the message status as well. So message status, oops, here, and the message status is result sets. Message status, there you go. From here, I'm just gonna do the outputs from the compose. Let me rename this to compose JSON payload to return. That's a very long name, but you get the idea. Compose JSON. Yeah. Obviously, you can pick another name, a more descriptive name than that. But when I put it here in the body is what's going to get response reply back to the caller that called that HTTP client, the body. And that's it. I'm going to save it. Oh, and we got an error. Has type response that could not be nested. Okay, so it doesn't like that it's on the for each. So we have to compose the JSON, but we only have the for each. But we have to compose the JSON from the first row of the store procedure. And we know it's only the first row because we know that it only returns one row. We just happen to know that. So let's try something different here. Let's see if I can do array under built-in. Oh, that's just for mapping from one value to the other. So that's not what we want. Let's see. Let me delete that. Collection. Data operations. So let's go to the category of data operations, compose, which what we saw. Create HTML table, we want that. Filter array. It might be it, but I don't think it is. Join, parse JSON, select. Maybe join is what we need. Actually, let me actually not do anything here. Let me try replying back the result set as it is and see what happens. So I'm gonna move this response here. I'm gonna delete this guy. And I'm actually going to return back the result set instead of the body. So I'm gonna output table 1. So out of my result set, the first table. Let's see what happens. That's the beauty of it. You know, you have to experiment with it and see if it works for you. So we're gonna run with payload because we need to add some parameters. So we're gonna run with payload. So we have put a body here. Remember our logic app takes 2 parameters, first name and last name. So we're gonna copy that as our body, as a body. So just this for testing, and we're basically acting as a client, the client of the API, and then we're telling our logic app, hey, these are the parameters that we want to add. So John Smith. So we're gonna run it. And sure enough, this is the response body. Notice that it transformed the table, the SQL table, automatically into an array, a JSON array. And within the array, it put that, it put the results. Now, sometimes it's better to use not to return an array itself on an API. You want to return an object always, and then if you do have an array, then put that array into a property of the object. So let's do that. Let's do a compose in here to compose our JSON. Compose, and then we're gonna do this. We're gonna tell, and this is gonna be our response object. And there's a standard. So many APIs take as a standard a property called name. I'm sorry, a property with a name called items to contain the items to be returned by the API. So we're gonna do table 1 as we did before, and hopefully this will work. Compose response object. So in our response, we're gonna, instead of doing this, we're gonna return the compose. Let's save it and let's see what happens. And I probably should have copy and pasted that payload, yeah, because it's not going to show it here. So next time this time I'm gonna copy and paste it so I don't lose it. John. Oopsies. Let's do this John. And last name, Baptist. Copy this. I'm gonna put it somewhere here on my computer that you won't be able to see. So bear with me a little bit, a few seconds here, while I paste this somewhere else where we can reuse it later. I'm gonna run it. And sure enough, look, it has our object, items, and then the items have an array, a collection, which in this case is only one row. So now we have a logic app that executes, calls our start procedure, and transforms the results of the start procedure into a JSON-friendly payload that a typical HTTP client can run. So one thing I wanted to show you is Google Resource API Guide. You're gonna see when designing APIs, it's always good to base your API design on another company's API design guidelines. For example, Microsoft or Google. This is just an example. So naming conventions. It's always good to follow their conventions. You can also follow the convention from Microsoft. I believe there's also one from Microsoft API design guidelines. You can also follow their guidelines. I believe it's here. Yep. So you can read this link right here. You can look for API Microsoft API guidelines, and that's going to allow you, if you can copy those guidelines for yourself, for your APIs, that way whoever's consuming the APIs will know, there would be higher chances that they'll feel more familiar because they might have interacted with APIs from Microsoft. So your APIs will be matching Microsoft's style of APIs. So we have this, and we have the only way to invoke it is through this weird URL, but we're gonna fix that. We want to actually create an API gateway, again without code. We're gonna create an API gateway that people can call in order to get our API. So we're gonna save this. So we already have activities already saved. And by the way, there's a story about source control and continuous integration for Logic App as well, but we're not gonna touch on that. Remember, keep in mind that Logic Apps is basically a workflow, a JSON-based workflow. It's a declarative workflow. So that, because it's based on code, it's possible to do source control on Logic Apps. But we won't touch on that right now. We are going to go back to our Logic App settings. Now that we're done with the logic of the Logic App, what we want to do is we want to make sure we're gonna keep it like this. We have to tell it that only certain people, certain things can call it, but we're not gonna do that yet. What we're gonna do is that we're gonna expose this through our API gateway. Our API gateway, we have our API gateway here on my resource. I don't have APM Juanito learn, so this is my API management service, and it's a consumption based, so I don't get charged. I only get charged when it's being used. So I'm going to define my first API here. So in here is almost a wizard type thing. You could also define it using PowerShell and Bicep, but we're just going to use the portal for now. So I'm going to tell it that I want to create from a definition, or actually from an Azure resource. Notice that it's already one for Logic App. So I'm going to cheat a little bit and then just click on that. And then I'm going to go to my Logic App. Notice that my Logic App is listed there. Let's select on that. And then I have to define my URL suffix. So my URL suffix is going to be what's going to be at the end of my URL for clients to call. So I'm going to call it students. And I call it students because right now we only have one operation, but eventually we'll grow into more API operations, meaning more logic apps. But for now, it's only going to point to one logic app. So, but we're going to keep our API URL suffix as students. If I click on full here, and my description is students API for doing operations on student related data for student academics. So students, and we can even call academics. And we can just do types of students. A tag is a way to organize the APIs. We're not going to deal with products yet. We'll see that later. And sure, we can version this API. And we're going to do it on the header. Actually, let's not version the API. No, let's not do that now. Create that. And as you can see, the auto-generated APIs here. Notice that it actually gave the name Logic SQL API Test. I don't like that name. Let's change that name. Should have been called academic students. I don't know why I put that name. That was a bad name. Name it students academics. And it didn't take my my description I put. Interesting. We're gonna require subscription, yes, and we definitely want to enable insights. I'm gonna put on my application insights. We can take a look at application insights later, but you definitely want to use application insights or some sort of type monitoring for your APIs. That will help you a lot on troubleshooting. Click on save. Now in the design, the operations are here. So notice there's only one post and it's called manual invoke. That doesn't make sense. Let me show you how this is defined. The operations are operations that your API can do. So I'm gonna go to WAML. We could keep on JSON, but I want to show you on WAML because I feel it's simpler. So instead of this path, manual invoke, I want to tell it that student enroll. Students, well, actually we already have students academics, so we can call it enroll. And instead of trigger a run of logic app, enroll student into school. Again, that's a silly example, but it's a very simplified example, but you get the idea. The operation ID, notice that it already generated manual invoke because it was invoking a logic app. You want to change that. I typically use the name of the path. I'm sorry, I usually do the path plus the operation. So post, enroll. And the summary, I give it a friendly name. I can typically use this description. Enroll student into school. Parameters. So notice that in the parameters, we have request manual. That's a bad name. It just means that it just means that this is the parameters that it needs, and I'm not sure why. Oh, you can see the first name and last name. The name is terrible. I don't like the name at all. It's in the body, but it basically means that the object in the body, like we saw earlier, it needs to have a first name and a last name. So this schema is saying, hey, this object, this structure, this data structure is defined under definitions and under request manual. So I'm gonna change that name because I do not like that name. And I don't know why I use Swagger 2.0. There's a newer version called 3.0, but we can change that later in another video. So I'm gonna name this student enrollment. Enrollment request. And then obviously because I changed it here, I gotta change it over here as well. That's the unique name of the definition. Everything's fine. The example, I can do John Smith. This the API, the Open API specification allows you to provide examples of what you're expecting. And the JSON response, I don't know why it never auto generates that, but we'll define it later. It consumes JSON, it produces JSON. Okay, so when I save it, so in another video we'll define that the output, so it's easier for clients to call this. So now we have our API, our nicer looking API. And this API is requiring a subscription key. So if I go to test, notice that in here the test, it allows me to test it. And over here is, you can see the row request that's going to be shown, that's going to be added. And I believe this requires a subscription key. So the test is going to do that automatically for us. It's going to add the subscription key automatically. So let's run it. It's a bad request. They didn't like it. The API version parameter is required for all requests. And that's maybe, let me trace it to see exactly what's going on, where the error was. And I can also see the error if I go to my application analytics. If I go to App Insights, which is not here. That's not the one. It's not there. So we'll take a look later. But it's saying that the API version doesn't like it, and that's because maybe we require that here.